Alright, so we're doing PreQuest, open that page. There's PreQuest number 1. We're going to number 2. Alright, PreQuest number 2.
Thank you.
Alright, so here we are, PreQuest number 2. Alright, everybody's paying close attention because we're going to have a quest, our actual quest, another 50-point quest over this. When do I see you guys again? I see you
Monday.
Friday.
I see you Thursday and then Friday, so the quest will be Friday.
Oh, I'm not gonna be here.
And you have to make arrangements with me, and I would strongly suggest you take it before you leave, but it's up to you.
I got you on Thursday.
Completely up to you. Alright, here we go. 201 degrees. Now listen, we gotta start pulling this stuff together. Convert to rectangular coordinates. That means find x and y. The word coordinates implies an ordered pair, right? So I am going to find an x and a y. Now we talked about this. What does x always equal?
Cosine.
No, well, x equals r cosine theta. Write that down, memorize it, go ahead and do y while you're at it. You have got to remember this. So those of you that said x is cosine, you're right, x is associated with cosine. X goes with cosine. But x equals r cosine theta. Okay? And y equals r sine theta. So, if I want to know what x and y are, all I have to do is 4 cosine 201, 4 sine 201. That's it. That's all there is to it. Then I go to my calculator. 4 cosine 201. Make sure you're in degrees. I don't know whose calculator you're using or how you got it set up. But 4 cosine 201 is negative 3.73. And 4 sine 201 is negative 1.43. That's it. That's all there is to it. Now, I'm going to have you do something here. I want you to skip down to number 4. Because number 4 is the same, number 4 is the same kind of thing. Number 4 says, change to rectangular form. Anytime it says change to rectangular, it means find what? X and Y. So looking at this problem, this is number 4 now. X equals 6 cosine 12 and y equals 6 sine 12. Remember, when a number is written in polar form, it's r cis theta. This is the r, this is the theta. So x is going to be 6 cosine, y is going to be 6 sine. So I type it in on my calculator. And I get 5.87 and 1.25. Now, here's the difference. Look at problem 1 and problem 4. Do you see how the problem is written differently? Problem 1 says, find coordinates. That's an ordered pair. Problem 4 says, change it into this form, and CIS has an I in it. So this is going to be written as x plus yi. Now, is it the same x and the same y? Yes. The only difference is, instead of writing it as an ordered pair, I'm writing it as x plus yi. When it says coordinates, write it as an ordered pair. If it says write it in some other kind of form, it doesn't say coordinates, it just says form, it means with the I. Now, I had you do number 1 and number 4 together because they're the same. You're doing the exact same thing. Do you see that? Anytime it says change to rectangular, convert to rectangular, that means find X and Y. Now, problem 2 and 3 say change to polar. That means we have to find R and theta. So everybody's paying attention now. To find R and theta, you're going to draw a picture. So in this case, I'm going left 5 and up 2. This number is R. So what would R be? R is easy. What is it? Not root 7. Watch your arithmetic. Square root of 29. We're doing the Pythagorean theorem. There's too much talking. If it's math talk, that's fine. If it's other crap, stop it. Okay, so left 5 up to root 29, Pythagorean theorem, right? That's R. Period. Now, this is theta. You can't find it. You gotta find this one. You gotta be inside the triangle. So who remembers, I need my calculator, second tangent to this. You can take or leave the negative, I don't care, I never put it in personally. And it's always y over x. Opposite over adjacent, that's tangent. So that works out to be 21.8. Now, 21.8 is not theta. Remember, this is theta. So we're going to do 180 minus that number, and it's 158.2. Now, notice the way I wrote my answer. Do you see how I wrote it in ordered pair form? Because the question says, question number 2 says, find polar coordinates. When it says find coordinates, you're going to write your answer as a parentheses. Now, number 3, convert to polar. It's exactly the same thing. You're going to draw a picture, -3, 1, that is left 3, up 1. There's an understood 1 on that eye. Does everybody see that? So it's left 3, up 1. So what's your R?
3.
No, Pythagorean theorem. Square, add them up and square root. Square root of 10. You know what? This is too important to be guessing. If you need to write down a squared plus b squared equals c squared, do that so you get it right. So R is root 10. Now, this is theta, just like before, right? So we're going to second tangent to find that angle right there. So second tangent 1/3, and I got 18.43. Whatever that was, I missed it. So what is 161.8? I'm gonna find theta by subtracting from 180. So the actual theta is 161.57. Now, does problem 3 say find polar coordinates? No. Problem 3 has an I in it. So when you write your answer, you're going to write it like this, with an I in it. So it will be root 10 CIS 161.57. That's the answer to number 3. Now, for problems 2 and 3, did I find R and theta in exactly the same way? Yes. The only difference is polar coordinates means write it in an ordered pair. Polar form means use the CIS.
The only time where you would write out like for example, number 4, 6 cosine 12, is that only when it's rectangular?
No, that is the long form. So you could write that out. Oh, wait a minute. You mean like this?
Yeah.
That's when I'm finding rectangular.
Okay.
If I need to know what X is, that's what I do. Okay? Because this is R and theta. So if I have R and theta and I'm finding X and Y, that's how I do it. Okay? Alright, so let's turn the page and look at number 5.
Wait, this is 4.
Yep.
You do what you're about to do with that one. Like write that in the long form.
The longhand form
Yeah.
is root 10 cosine 161 plus I sine 161. That's the longhand form of this shorthand form.
They both don't get root 10.
No, because there's a parenthesis there.
Oh, I see.
All right, number 5. Convert to a polar equation. Now, that means that you cannot have our X and Y. You can't have X and Y. These are the really easy ones. Does anybody remember how to do these? They are super simple. What does X equal? R cosine theta. So I'm going to take that X out and I'm going to write R cosine theta instead. And then I'm going to take the Y out and write R sine theta. And you're done. That's the answer. That's it. The directions said get rid of X and Y and put in R's and thetas. So that's what I did. That's number 4 or 5, convert to a polar equation. So we started with this. Do you want to take a picture of mine? We started with this and we're ending up with this. It's one step.
Yeah.
Plug in, done. Now the next one is the opposite of that. And it is a little bit harder. This is a polar equation. Would you agree with that? We want to make it look like this one. Okay? Now, I went through the steps with you one day. Does anybody remember what the steps are? The first thing we do is change the function. So, it may be a cosine, it may be a sine, it may be a secant, it may be something else. It doesn't matter. What's the definition of it? All right, this is a cosine. What's the definition of cosine? X over R. Asia, what are you doing over there on that iPad? Is that math? Don't you lie to me. Okay, put it away then. We don't need to have it on. Cosine is X over R. You're exactly right. So whatever the function is, plug it in. So sine would be Y over R. Tangent would be Y over X. And so on and so on. Now, who remembers what the second step is then? Always. Yeah, the second, when you plug this in, it's always going to be a fraction. Get rid of the denominator. So in this case, we'll multiply by R. So R squared equals 2X. And then who remembers what's R squared? X squared plus Y squared. Yep. Every one of these that you do is going to have those 3 steps involved. All right. Now, number 7. All right, so our 2 numbers are 10 CIS 60 and 5 CIS 70. And we are going to multiply them and divide them. So who remembers the rules? This is one of the very last things we learned. Who remembers the rules for multiplying numbers in polar form? What do we do?
Multiply first two.
Okay, so we multiply the r's, so that would be 50. And then we add the angles, so that would be 130. And we're done. Now, do you remember we did an example where when we added, this came out to be a big giant number? And then we take 360 away from it to shrink it down. We don't have to do that with this one, obviously. It's okay. All right, now what's the rule for division? Now we're going to divide them. So we divide the r's, so that would be 2, 10 over 5. And then we subtract, we subtract, and that's what we get. But what did we say about negative angles? Rather not have them. So what's the positive equivalent of negative 10? Positive 350. How did she get 350? This is the
Added
answer.
360.
She added 360. Okay, you're always going to either add 360 or subtract 360. Always. Now, if you put this down, you're going to get most credit. If you put this down, you're going to get all the credit. Okay? And then we've got one of these. These are the longest ones. These are several steps. Answer in polar form. Okay, here we go. All right. Who remembers? We did a few of these. This is the very last thing we learned in our notes.
One gets taken to the 6th power, and then the next one multiplies.
No, first, we're going to do that, but first we have to make our number look like these guys. Okay, they need to look like that. So let's draw a picture of this. You got it? Now, this is R. How long is R? 2 root 2, or the square root of 8. Now, that I'm not going to put that in the answer blank, so I'm just going to leave it square root of 8. But if you want to do 2 root 2, you can. It's the same thing. This is my theta. Now, you might be able to tell that's a 2 and that's a 2. How big is this angle? 45. If you can't tell that, you're going to have a calculator and you'll do second tangent. Right, Robbie? But I know that's 45 because these two match, and that's what happens in a 45 triangle, they match. So what's my actual theta? That's 45, so this would be 315. So my number is the square root of 8, CIS 315, and that's what I'm going to raise to the 6th power. Now remember, you have a calculator. What you need to do, as Deshawn said, is take the square root of 8 to the 6th. Remember, you take the R number to the power. And then what do we do with the 130 or 315? Multiply it times 6. So we have a calculator. We can do that. When you raise to the 6th power, remember you use this key. So you put in your number and then use your little caret. So you should have gotten 512. And then 315 times 6. Oh Lord, 1890. Are we good with that? Is that going to be a full credit answer? Yeah, 1890 is like way too big. So does that actually come down to 90?
Yeah.
So your answer is 512 CIS 90. And notice the directions say answer in polar form. That's it. You're done. That's the answer. All right, I'm missing, where's Morgan? I saw her this morning.
She had an appointment.
But our quiz is not over this, right? It's over the graph.
But we're not done with the pre-test yet. So Althea, just stay here for a minute.
Well, I am.
Is that all I'm missing? Looks like it. Okay. All right, now go to the graphing page, all right? The last page, this is your graphing.
Tired.
All right, here we go. This is our graphing. We're gonna plot these points.
But it's not on the plate.
Yeah, it's not. I took that earlier.
All right, here we are. Here we go. We're gonna plot the point 5, 7 pi over 6. Now, the graph paper, the grid that I gave you, is set up in degrees. So you are probably gonna wanna change this guy into degrees. So you have pi, which is 180, divided by 6, which is 30, times 7, which is 210. So you're gonna get on the 210 circle, the line labeled 210, and you're gonna count out 1, 2, 3, 4, 5 circles. So there's where 5, 2, 10 is gonna be located. Now, the next one is problematic. Who remembers how to deal with that? You flip it. You cannot get, this tells you which circle to get on. You know, here we got on the 5th circle. There's no -3 circle. So what does that negative tell me? You gotta flip the point. So instead of plotting it at 270, which is down here, it's gonna get plotted where? 90. Because we go to the opposite side of the circle. And the opposite side is how many degrees different? If you go from this side of the circle to this, it's 180.
Okay.
When we change the sign on the radius, when we flip the point, like somebody said, this tells me to flip the point. So instead of being at 270, it's flipped up here to 90. The negative tells me to flip the point. All right, now, one question left. We're gonna graph this thing. So those of you that have calculators, get them out. You must be in polar mode. So make sure you are in polar mode. And that's all I'm gonna say. I want you to mess with it a minute and see what kind of thing you can do.
That's the reward I get. Is that how it's
And once you get a picture, I want you to see if you can carefully reproduce it onto that grid there. Because that's what's going to happen on test day. I have to grade your paper. So you need to be able to draw your curve on the paper.
This is like a little for children when they can't do that.
That's what they did.
not making
Oh my God.
Hey, can you quiet down to the left and freak out?
I do a Joseph's talk all day, every day in this class. I don't need this.
that right there is just But no, hey, are really correct. That little thing at the top of the
Tommy's like, I'm handsome.
That's the shape that you should be getting.
What is our window supposed to be?
I want you to figure that out because I am not going to tell you on test day. So play with it a little bit. So take a few more minutes and see if you can get this picture.
Make sure that you're
I'm
clearly.
Did you get this picture?
not.
All right, well, hurry up. Put it in your calculator. Make sure you are in polar mode. Robbie, did you get this picture? Robbie? Okay. Mess around with it. Practice with it. Problem solve. I'm not going to be sitting here telling you how to do it on test day.
My calculator says it's reverse.
Has anybody gotten this picture? All right, let's wait till we get a couple more people and then we're going to hear some ideas about how to set it up.
So this is what our quiz is about to be over? Just this?
No,
Oh, we're taking a quest today?
no, we're taking a
No,
quiz
we're taking a
and we're going to talk about that in a minute, but I want to get this done.
Yeah,
Notice there aren't very many problems on this quest. So if you leave number 10 blank, it's going to significantly probably be a letter grade, right? So there's only 10 questions, there aren't very many questions. So every one's going to be worth a lot, and you can't just leave it blank. You have to be able to figure this out. And sitting there waiting for other people is not the answer.
What's in your mouth?
Okay, so make sure you are in polar mode.
This is weird.
Go ahead and put it in degrees if it's not already. It probably is already in degrees. And you go to your window. You are in degrees. What will theta, min, and max be if you are in degrees? 0 and 360. Kids, come on. You need to go around one time. Are you spiraling? No, this is not a spiral. You need to go around one time to get the picture. Theta step, what did I tell you about that? 1 is fine, but for degrees, 3 is better. It goes faster with 3, but 1 would work. What about your X and Y maxes and mins? -6 and +6 would be fine, because as you can see, this picture is 5 wide. Now, if you put in your equation the way you're supposed to and hit graph, you should see that right there.
Wait, what's
When you reproduce this graph, now that's not perfect. I am not an artist. But notice, how far out did it go? 5. 5. Because that's what it did on my calculator. If you draw this, but you have it shorter or longer, you're going to miss points. You've got to have the size right. The shape may not be perfectly symmetric and all that, but you've got to have the size right. See the little loop in here?
Mm-hmm.
It's 1 big. You got to have that little loop in there being 1 big.
God bless you.
Yeah, bless you, bro.
Now, we got it?
Wait.
So what's the scale?
Just leave the scale always at 1. There's no need for you guys to be changing that.
Okay, so what's the Y? The Y max?
Y min 6 and Y max is you're -6 and 6.
Yeah, for the X.
What do you put in for it?
Type this in.
I'm not getting right answer.
No, type this is.
It's -6.
Oh, that's right.
Wait, how did you type those in?
Oh,
Like
no.
the equation is?
I don't know. No, we're on this one.
Alright, so we got the shape, everybody?
Then you hit anything else.
Alright, now,
She just pulled.
you need
What's the X?
to be able to do that on your own.
This is what
You
I
have a
got.
plot turned on, so it might take us right there. I don't know if it's gonna graph with that plot turned on, so it's on top.
It kind of looks like an apple.
Oh, I have it as 3.
Joseph, you're supposed to be doing number 10, fool.
Yeah. That's all that's draw. Otherwise, the min's always negative, max is always positive.
Right on.
Set it up right. I don't know that you got anything set up right. Okay. All right, now we're going to talk a minute about our quiz, okay? Now, this kind of thing right here that we're just doing is what happens when you're not paying attention the day we go through all this. I'm not reteaching you how to graph. We spent a whole bunch of time on that. We graphed a whole bunch of curves. You need to go back and look at your notes or go back and watch the video, okay? One thing that is not on the quest that we need, that what we're going to take a quiz over right now, or soon, is this whole notion of the classical curves. Which classical curve did you just graph? Which one is this? That's a lima sign. And remember, we talked about lima sign because it has the shape of a lima bean, right? Now, there are special lima signs. Let me write this equation down. The one you graphed was 2 minus 3 cosine. There are special lima signs called cardioids. The question might be, is this equation a cardioid? And you would say no, because these two numbers aren't the same. We've talked about this now 3 times. These two numbers aren't the same, right? So it's not a cardioid, but it is a lima sign. Now, so that's one of our classical curves. Right there's a picture of it. Who can name another of the classical curves? The rose. Now, you don't need to know, I mean, I'm not going to say to you, write the equation of a rose. You don't need to know that. But if I write the equation of a rose, you need to be able to tell me 2 things about it. That's 2 of them. That's 2 roses. You need to be able to tell me 2 things about them. What are the 2 things I'm going to want to know about a rose? How many leaves are there and how long are they? So how many, how long? All right. So for equation A, how many leaves are there? Who remembers the rules?
2, 8. 8.
No, it's 8.
Right?
7.
Stop. It's 8. If it's even, multiply by 2, and if it's odd, then it's the same.
16.
There are 16 leaves. Why are there 16 leaves? Because the number on theta controls the number of leaves. The coefficient on theta controls the number of leaves. If it's an odd number, that's how many leaves there are. If it's an even number, there are twice that many, right? So 8 is an even number, so there are 16 leaves. How long are they? 4. That number tells you how long they are. So for B, how many? There are 7 of them. This number tells you how many there are. If it is an odd number, that's how many there are. If it's an even number, there are twice that many. How long are they in equation B? 5. So both of those would be example of roses, and we now know how many leaves and how long they are. All right, so we have the lima sign and we have the rose. We have the, well, that's right. We say lemniscate, but we think lemniscate because it tells me that, or that tells me it's a figure 8. So it'll look something like this, some shape like that. Now, the question we'll need to answer about a lemniscate is, this will be the kind of equation. That's the equation of a lemniscate. Remember, it is the one with a square, right?
Yeah.
I might say, now it's a figure 8, okay? I might ask you how long these leaves are, just like with a rose. How long are those leaves? How long do you think the leaves are here? They're not 9, be careful.
4.
No, that's an R squared. If you take the square root, which is what you have to do to graph it, right? We gotta take the square root to graph it. This is how long the leaves are. The square root of 9, which is 3. So if we had R squared equals 16 sine 2 theta, those leaves would be 4 long. Okay? So we got the limacine, the rose, the lemniscate. What's the 4th classical curve? The spiral. And spirals are of 2 forms. You can have a spiral that looks like this, and you can have a spiral that looks like this. And that doesn't have to be a 3, that can be any number. Okay? What is the difference between these 2 spirals? One starts out here and spins in closer and closer and closer. And one starts in here and spins out farther and farther and farther. Maybe at the prom we'll do a dance together. Okay? Now, which is which? Who knows? Who knows which is which? One of them is in the spiral of Archimedes, and that's this one. The spiral of Archimedes. And the other one is a hyperbolic spiral. That's this one. This is the one that starts here and goes out. This is the one that starts out here and comes in. That's all you have to know. Now, what if I say to you, name the 4 classical curves? Don't look at the board. Can you name the 4 classical curves? Lemniscate, rose, spiral, limacine. Right? Luckily, you don't have to pronounce them. You just have to write them down. But you have to write them down so it looks like what you're saying. Well, what if I said, graph a freehand lemniscate? What would you graph? A figure 8. What if I said, graph a rose?
Flower.
So yeah, and you can make it however you want. An example would be maybe like this. That would be a rose. You could, that has 4 leaves. You could have more than that or less than that. You get a 3. What if I said sketch a spiral? Just one way or the other, right? Spin it out. And then what if I said a limacine? That would be a lima bean, and that would be like the picture that I erased here that we had on the grid. So you would draw something that looks like this. That would be an example of a limacine, right? All right, what if I said, how many leaves does this have? How many leaves or petals does that have? That's rose. 20. Why do I know it has 20? That number is even, and when that number is even, there are double. What if I said Is this a cardioid?
Yes.
Yes, they're
You
saying.
would say yes, because both of these numbers are 5s. What if I said, where would you plot the point -4, 25 degrees? What if I said, where would you plot that? You cannot plot it on a negative circle. That's an R value. So we're gonna flip it. And if you flip it, where will that be? What angle will you flip it to? 205. And why do we flip it to 205? Because when we flip it from here to here, right? And how many degrees is that? 180. So 25 plus 180 would put me at 205. Okay? All right, we're going to take a quiz here in a few minutes. I'm going to give you 5 minutes to study, cram, help each other, whatever. The quiz is no calculator.
Oh.
If you need to go to the restroom, let's do it right now.
Ah, bro, why are you hitting me?
And then we're going to take our quiz. And then when we come back, we're going to do a little bit more review.
You pause it.